What's going on, Algebra Bros? It's Mr. C here, and in this video, I'm going to go ahead and work out an example involving the exponential law. And I'd like to dedicate this video to one of my all-time favorite bands, Alice in Chains. As you can see to the right, we have a picture which is the album artwork for their album Jar of Flies. Check it out. Awesome, awesome CD. Anyway, we have the size A of a certain insect population at time t, which the units for time in this example is days. It obeys the function a of t equals 400 times e to the 0.06t. All right, so that right there is in the format of the exponential law. And we're going to use that function right there to answer these three different parts. The first part wants us to determine the initial amount of insects. If ever you're asked for an initial amount of anything, provided you're working with the exponential law, that's always going to be your value of a sub 0. So our value of a sub 0, just by comparison, is 400. And I'm going to note here that a sub 0 is equal to 400. All right? And that would be 400 insects. So you can get that value just by comparing your particular exponential law function with the generic version of the exponential law. Another way of doing this is to simply plug 0 into your provided function, in which case you'd have a of 0 equaling 400, e to 0.06 times 0. Of course, this right here will equal 0, so you get 400 e to the 0, and we know that e to the 0 is going to equal 1. And so kind of in a more roundabout way, we get the same answer of 400 insects. Whichever way you prefer is the way I recommend you do it. Okay, both ways will lead you to the right answer. Now it wants us to provide the growth rate of the insect population. We're going to get that answer from the value that's in front of t in the power. So I'll write that out here. K equals 0.06. So that value that's in front of the variable t in the exponent of e is always going to be your rate. Now notice that the value of k is greater than 0, which means that we are working with the law of uninhibited growth. All right, so this would be a sufficient answer, k equals 0.06, but I would like to offer an interpretation of that. 0.06, if you converted that to a percent, works out to be 6%, which means that the population of insects or bugs grows by 6% with each unit of time. In this case, our unit of time is days. So the population of insects grows by 6% each day. Pretty fast. So that takes us to our last part here. What is the insect population after 10 days? So the value of 10 days right here is a particular value of t. And what you'll do is just take that value of t and plug it into the function that was provided in the instructions. In other words, we'll do a of 10. And we have 400 e, and in its power, 0.06 times 10. And if you punch that in your graphing calculator, rounding to the nearest insect or nearest bug, we should have about 729 insects. So that would be the population after 10 days have gone by. All right, and that's how we solve this problem. Let me know if you have any questions. Otherwise, thanks for watching, and I'll see you in the next video.